Alrighty, let's get back on the speeder bike build. And I figured I'd do one more with the speeder bike and then I'll get back to the Jaguar because it's been way too long since I've done anything on that Jaguar. And, I'd like to get them both done eventually. But I'm going to continue with the front area here, and more specifically, this center part right there. And one thing I want to mention. I've been basing everything I'm doing roughly on the model kit. But when I look at reference photos online, for example, I wanted to see better what this pipe right here would be like, looking at other reference photos. And, there's so many different interpretations. And everybody who has their own interpretation does everything slightly different. Even when you look at images that I think are supposed to be canon, maybe, there's slight differences. So it's hard to know what's right. And, for as lack of exact information as I can find, it almost seems like this is just a made-up thing that doesn't actually exist. For example, one thing, I've seen a lot of images of these front pieces here, and from as far as I can tell from the kit, it works exactly the way I did it here, pivoting like this. That's how the model kit looks like it's supposed to work. But I've seen several people make theirs to where this part is like a linear actuator and it hinges here, so it would do more this, which I don't know. I mean, I don't know. So I'm just throwing it out there because I know there's going to be some commenters that are going to be like, oh, you didn't have that moving right, or you didn't have that pipe right. But you know what? This is my interpretation. So whether it's right, wrong, or indifferent, good luck proving me wrong. But I have no idea. So I'm still on the fence as far as how I want to do these pipes along here. Not sure about that yet. But I want to focus on this piece right here, and then that piece up front, and then I'll do those pieces. So for that piece, I got it all laid out on a piece of aluminum. And you can see my layout lines. I'm going to have to mill in. You'll notice there's like a ridge through there, so I'm going to have to mill in to take some of that material off. I don't want to cut these corners off yet, because to mill that out, I'm going to have to somehow clamp that down to the table of the mill. And I think I want that on there to give me something to clamp onto. So I'm going to leave those on for now. But while it was in the mill squaring it up, I went ahead and popped the holes in. That's where it will screw to the arms here. And I also put a couple of holes in right here. And I'm thinking I'm going to use that to screw that piece right there onto. But the next step is to mill out the pockets in those arms that will screw into. Now, I'm going to be using the digital readout. And while this was in the mill, I set the digital readout at that center point right there and at that edge for 0, 0. And then I came up here and over for that hole in here, and then down for those two holes. I'm going to use that same 0 point to locate the holes in the rails so that the holes are spaced exactly the same. And I still consider myself like a novice with the milling machine. So I've seen guys on YouTube like using the DRO, and it almost seems like they just have the numbers they need memorized. For me, I've got to make a plan. So that's what this is all about. So finding my first central point from where I want to start, which is basically in line here. So I measured this from here to here. So I know from here to here how far I want to start that. So I start that point, and then I add that dimension, which is 68.4, but I need to add half of the diameter of the cutter. And then from there, I set my new 0, 0 point. So then I could come up to mill out the pocket. And so I gave myself, those are the DRO readings for X and Y. Those are not the actual dimensions. Because something that would be really easy to forget about is adding or subtracting your cutter diameter or radius. Because sometimes you need to add the diameter or subtract the diameter. Sometimes you need to add or subtract the radius. So I sketched out the plan for that, giving myself the coordinates. So now when I go to the mill, I just follow my coordinates and it should be good. So let's go take a look at the milling machine and we'll see how we have this set up. Okay, so on the mill, I've got the bottom cross brace clamped in here. Ignore those numbers. I need to get rid of those. That was for something else. And I put a spreader bar of aluminum on the other side because when you're cranking down on your vise, you need to have the clamping force kind of even. If I would have just put that piece there, the vise would have wanted to twist. So I put a spreader bar on that side that was the same length. So now I've got even force so the vise isn't trying to twist weird. And so that clamps that end. And for this end, I put some spacers up. This is a piece of copper that just rested under the arms. Another piece of copper, an aluminum block, and then the tie-down blocks right there, the clamping blocks there. And to make sure that it's perfectly, this way, I used my electric edge finder to find that edge and then that edge and found center. And then I scrolled it all the way over to here. And then I made sure that as it went to that edge and then back into that edge and back, that those distances were the same. And I basically just tapped this back and forth until they were. And so now I know that these rods are perfectly as good as I can get them, like parallel to where the center line of the rods is parallel to the mill. Because these rods are tapered and they come off of that front point at an angle. So there's nothing here that's like square or true. Everything's at its own angle, its own taper. But I want to make sure that the center line that goes between the rods is perpendicular or parallel to the mill. Also, I made up this block right here to lock that end down. Because the actual pieces that go on here, there's one piece that bolts here, which would allow it to rock. There's a separate piece that goes here that would allow it to rock. So even with those two pieces bolted on, this thing is capable of twisting because it's basically just a big parallelogram. So by having one plate with the 4 holes, that locks that in. So everything is symmetrical and even and true, pair, level, whatever you want to say. As good as I can get it. So now I'm just going to follow my DRO measurements. So again, I started with 0, 0 here, moved out to where I wanted. That's my new 0, 0. So now I got to go that way, mill out the pocket, come this way, mill out the pocket, and then put the holes in. And hopefully that works. So yeah, let's give it a go. And by the way, that yellowish, goldish color here, that'll all be sanded off. That's only there because the aluminum I used was anodized. It was like a orange or yellowy anodized. So that'll be sanded off. And also these tabs right here, I think they're too wide. I'm going to narrow those down just a little bit. I think I'm okay with these, but those, I'm going to take that thing off and narrow those down just a tiny bit. But let's get the mill going and see if we can get those pockets milled out there. Now I just have to flip all the DRO readings over this way and do that again. Then I can put the 2 holes in it for the screws. And real quick here, I didn't mention before, the 4 circles there, that's my cutter path. Those aren't the holes for the screws. There's only 2 holes for screws. I really didn't need to even do those 2. I'm really concerned about that corner and that corner. And so basically, and I came down 4.7 millimeters, which is the thickness of the plate that's going to go in there. And when I was coming around, I stayed away from that edge until the final cut. So I was about 0.5 millimeter away from my final dimension until the final pass. Then I went to the exact numbers for the final pass. And that's looking pretty good, I think. So we'll get the other one done, and then we'll just put the holes in. Again, just doing the same thing with the DRO. So these are the DROs for the holes. This is for the plate that's going to go in there. And I did the DRO dimensions from center line instead of the edge. Notice they're 2.5 millimeters from the edge. But if the width of the plate, if the width of that plate is just very slightly different from the gap, from the pockets I'm making now, if I put the holes from the edge, then any difference between the 2 parts is going to translate into the difference for the hole spacing. So by doing the holes from the center line, they'll be exactly the same between the plate and the posts, and so then it should fit fine. At least that's my theory. That's what I'm going to do. We'll find out if it works when it's all done. Of course, I could be completely screwed up and wrong, but we'll find out here in just a little bit. So yeah, let me get the other one done. I'll get the holes in, and then we'll see how well it fits. Okay, so there it is, and both pockets are in. Holes are drilled and tapped, and this is the piece that's going to go in there. Obviously, we can't put it in there now, but just a preliminary fit. That is like perfect. And I tell you what, that DRO, I am so happy I bought that thing. You know, I was on the fence about getting one because of the price, and it really wasn't even that expensive. And I was also a little concerned about being able to install the scales on the mill, but it really wasn't that difficult. If you don't have a DRO on your mill, I tell you what, man, you're making life harder for yourself, maybe. I mean, I know there are people who are getting this level of accuracy all the time without a DRO. I would have really struggled, to be honest with you. Like I said, I've never claimed to be a professional machinist. But for me to get this kind of accuracy-ness without the DRO would have taken me so much longer. And I probably would have made it a little too big or oversized. But anyways, I'm just saying that thing was a great investment. If you don't have one, I would encourage you to just get one. And I promise you'll be happy with it. So anyways, let me get this thing off of the mill, and I need to cut this thing to shape so we can finally get it fit into there. Okay, I've got that piece set up in the mill to mill out those recesses. And remember I said I'm going to leave those on. I'll cut that off later. And this is kind of showing why I'm doing that, because I kind of need that to clamp down on. And obviously this is at just a random angle. So what I did was I set that line up parallel to the vise there. And I did that with an adjustable parallel. So I put a parallel in there that would stick up a little bit, butt that up against there, and then line that up with the scribed line. And that way I know that that is parallel to the mill. And so what I'm going to do is I got a little end mill in there. I'm just going to plunge down, and I'm only going down about 1 3/4 millimeter. It's less than 2 millimeter. So I'm just going to plunge down and mill along that line until I get to that scribed line right there. So again, I'm just going to go from about here to here, and that's it. And once I get that one, then flip it over and do this one. Then I'll just put that straight up against the fence there and do along here and take out the rest. And then I got to flip it over and do the same thing on the other side. That line in the middle there is a mistake. So I'm milling up to that line, and then later we'll cut it off at that line. And this is all just by eye, nothing with the DRO here. So don't think I'm really going to record this because it's probably going to take me a while. And I'm going to have my head right down in here. So yeah, we'll just mill those pockets out, and then we'll cut those corners off and round those corners here. And then we can finally bolt it onto the frame, or the onto the rails. Okay, so there's that part off of the mill, and both sides pocketed out. The black Sharpie there is so that I could regain the depth, because if you remember, I just milled a pocket here with that at an angle. Then I had to rotate at 90 and do the rest. So I had to come back in with a depth. So the Sharpie was there so I could see when I was matched up as best as I could. I'll go over all of that with some sandpaper to get rid of all of the machining lines. But now I can go through the bandsaw and cut off those corners here. So cut down in here, and then put that back in the mill and true up all those edges. And then we can finally test fit it into there and then work on that piece that gets bolted to the front. So let me get that cut out and we'll see how it fits. Okay, here it is off the mill, and see, I got it kind of pocketed out, and I think it came out pretty good. It's not perfect. Some of the edges are a little, I don't know. It'll look good though. I need to sand it because right now the machining marks are really shiny and you can see them. So I need to sand that all down. I need to take the sharp corners off, round those corners off. And I also chamfered around those edges where it's going to go down into here because the end mill is not going to leave a perfectly sharp edge. So I chamfered those off with a file. So let's see how this thing fits. And I'll be honest, I already fit it. But that goes in just like that. And pretty much perfect fit. I'm not bragging or anything. I'm just saying that I did a good job. That's all. So, well, you know what? I haven't tried these screws yet. So we'll see how well these screws line up. So I think I made the tolerances a little bit too tight because I had to chase a lot of those with the tap. But that's that in place. So the bottom side looks like, again, that's going to have to come off and get all sanded nice and smooth. The holes on the bottom there, that's okay, because when it's all together, you can't see those because the bottom chin is over that. Okay, so the next piece is this one right there that I will bolt to those two holes there, hopefully. And my first thought was to get a block and turn it on the lathe, but those aren't round, so a lathe wouldn't really look right for what it is, I don't think. So I've got the block of aluminum. Basically, I measured all the dimensions of this, and I've got my dimensions, and I just started laying it out on a block of aluminum, and that's kind of the basic shape of that. I just have to do the same thing over there. The center section should be straightforward. I could just mill that down. I think I'm just going to have to put it in the vise and just eyeball to the line and then file and sand it to shape, maybe. I don't know, should be interesting. Not too sure yet exactly how I'm going to go about that, but yeah, that's got to get tapered down. The two bolt holes are going to go here and here. And on this side, I'll bore in and countersink for the bolt heads. But I don't know. We'll see how it goes. It'll either work or it won't. Okay, so I did a few cuts on the mill. This is what it's looking like so far. The first thing I did was establish the holes, which, you know, I think that's just good advice in life in general, is to establish your hole. As you can see, I kind of just sketched out the basic shape. And as long as both sides are the same, you know, nothing on this is dimensionally critical. The only thing that's critical is that it is centered. That's why I did the holes first from the center line. And as long as everything I do on one side, I copy on the other side, then it should be fine. So I just scribed in some lines for where I need to make more cuts. I'm going to leave that on there till last. So I'm going to mill up, leaving that and over. So we'll basically just get rid of all of this and then do that shape last. So it's just a matter of deciding what you want to take off next, I guess. Order of operations is, I don't know how critical it is, but I can see that if you did the wrong thing first, it might make it difficult to hold it to take other things off. So I'm taking off what I think will affect it less first, if that makes any sense. Like I said before, it'll either work or it won't. Now, the cuts I'm making are pretty straight. And if you look at the kit version, they're a little bit curved. Once it's completely done on the mill, I'll go in there with like a Dremel tool and files and sandpaper, and I'll kind of make it all rounded a bit, just to kind of make it look a little bit more like the piece there. So anyways, let me do some more work on the mill, and then I'll come back and show you what it looks like. Okay, there's the part off of the milling machine, and these curves are still, you can still kind of see my scribe line. So I just took the bulk off of those corners there. So I need to shape that either with files or the belt sander. I'll do one, make a template, and then do the other one so they're the same. But that's what that is looking like so far. Counterboard in for the bolts. That will bolt it to that piece. And that will look something like that then, with both bolts in. And I think it looks pretty cool. The shape that I got in there, I think, looks pretty nice. So, like I said, I need a lot of filing and sanding before this one is considered done. And I just realized I need to put it back in the mill, because I forgot I need to take out just a little bit right here. I need to go in maybe, I don't know, 2 or 3 millimeters right there, take out that centerpiece. So that'll get cut down right there. So yeah, let me get all that done, and I'll just come back and show you what it looks like when it's all completed. Okay, here it is, pretty much done. I could probably do some more filing and sanding on it, but I think it's about 99% there. And I don't know, I'm really liking it. I'm very pleased with the way it turned out. It could have gone either way. There's what it would look like with the mounting bolts installed, or one of them at least. And of course this then gets bolted to that piece right there. And of course that piece I still need to file all the edges, get all the sharp edges off, sand it all smooth, and then that's ready to bolt on. And that's looking just like that. So yeah, I'm really pleased with this one. So I think the next thing I'm going to do is whatever those things are. I have no idea what to do with those, how to make those. I'm thinking, so on the top view, it looks like they go under that piece. And of course, for the kit, they just kind of disappear there. I'm thinking what I'm going to do is I'll make a tube that will mount to the bottom of that piece and then curve around and plug in. And I'll put a few details on it, but not really sure what else to do besides that. So I'm going to start looking for some tubes and start making some parts and see what I can come up with. All right, so I took some measurements of those pieces and kind of sketched them out here. And those are actual dimensions of what I'm going to be doing. And so I basically, that part right there, I turned that down out of a piece of brass. And I wanted that piece to be aluminum. And so basically I had some aluminum tubing that I just slid over the brass. So the brass part looks like this. And as you can see, I also put a couple of holes in it. We'll see what those are for here in a second. But yeah, that's just a piece of aluminum tubing that went over the brass. And I turned that in down a little bit more for that elbow piece. Now for the elbow, I found some of these steel hooks. And before I cut it apart, that's what that looked like, just a steel hook you screw into the wall to hang stuff on. So I cut that off and I drilled through the end, and then that goes on like that. And so that's what I turned that down for there. I also made a couple of aluminum pieces like this, and those go over that, and then that goes like that. And what this looks like all mounted, but also there's a little detail when you look at the kit parts. There's a little detail right here. I don't know if it's going to show in the camera very well, but there's a little detail right there that looks like ridges. And when I look at photos of other examples online, it kind of looks like a spring. So I found a couple of springs that just happen to fit over that almost perfect. They're a little bit too long, but so I'll either cut those down or I'll just wind something else different. But that's kind of what that's going to look like when it's assembled and together. Like I said, I either need to cut those springs or just take some copper wire and wrap something else separate. I'll figure that out later. But this is what it looks like mounted to the rail. So the two screws right here, just screwing it right into the rail. And again, there's the aluminum tube over the brass. There's that piece there that's into a pocket. And then the elbow piece that goes in right there. Now these are just, those are not glued or bonded on yet. All of this is only held on by those two screws. And with this piece, I also went in and milled out right there for the tube to kind of fit in, because this actually goes together like that. So that's what that looks like. And from the bottom, you can see I had to kind of mill into that ridge for that to fit. But that's what that looks like for one side. And again, comparing that to the kit part, I think that looks pretty good. I'm pretty pleased with that. So just to show you what this looks like, and what I'm going to do, I'm going to JB weld the angle piece into here, and I'm going to JB weld that piece into here. So that way, if anybody ever wants to take this apart for whatever reason, they just take out a couple of screws, and then that will pull out. But like I said, that will be JB welded. Those two pieces will be JB welded in right there. So this one just goes into a hole, and this one plugs into a rectangular pocket that I milled in for that to fit into. Just like that. It's a little bit of a tight fit. And I just used a little end mill. It's about 1.5 millimeter diameter end mill This is 3 millimeters wide, so just milled out the little pocket there. So let's go over to the milling machine and I'll show you the setup on how I mounted this to drill those details in there. So here it is in the mill. I got a V-block here, and I just have a piece of copper. Actually, that's probably brass. Got a piece of brass in there to protect the aluminum rod from the screw. So when I tighten that down, it doesn't damage the rod. And that V-block is clamped into the vise here. The other end, another V-block, and again, clamped piece of copper here. And a stack of, I don't know if that's good or not, but it works. If it works, it's not stupid. So I got some 1, 2, 3 blocks here, my normal clamping blocks. So this one is holding down the V blocks, and then that rod screws into the V blocks with another clamp on a block onto the copper, holding that end down here. So this thing is held tight at each end. So basically what I'm doing is I'm going to locate on the DRO, I'm going to locate 0 from that edge right there where the cross triangular piece screws in. And then I'm going to come over and drill the hole here, and then the rectangular pocket gets machined out, and then the other hole for the little elbow piece. And this is basically that plan for that. So again, there's where I find my 0. So there's one hole at 8.4 millimeters, another hole at 17, and then the last hole at 109.15, and then where that pocket gets milled out, and those are the DRO coordinates for that pocket. And again, I do this so that I don't screw up. So I basically go to those coordinates, down to those coordinates, over to those coordinates, back up, then I will run the end mill down about 0.5 millimeter and do it again. And again, I write everything down so that I don't get lost where I'm at and so that I don't screw up. So that's basically all of that right there is like my movements and my plan for that pocket right there. So anyways, let me just drill and do the holes on this one, and then we can put all of that stuff back together. Okay, so the next thing I want to do is the bell crank assembly here. The thing that's been bugging me about this since the first time I saw it is that if you look at the geometry here, so you have a bell crank here pointing back that looks like a pivot point. That looks like a pivot point here, which means this would want to swing around this way. But the way they have this rod coming in and curving in kind of doesn't make sense for that swinging back and forth this way. At least to me it doesn't. Now, I have seen a bunch of different interpretations of this. You go online and you just look up images, whether it's like a drawing or a model or whatever. There's dozens of different interpretations of all of this. I really want the model I'm making to be very close to this kit. But some interpretations of this I've seen had this piece, this bell crank rotating about that point. Other interpretations I've seen actually looked like this was supposed to slide fore and aft, which would make sense for that rod coming in the way it does here, but that looks like a pivot point here, and it does not look like anything to slide fore and aft. So I think the intention of this bell crank is to rotate about that point, but again, that doesn't explain this. And then if you look back here, well, this looks like some sort of an actuator. Now, whether it's hydraulic or pneumatic or electric, or if it's just a dash pot, you know, like those little strut rods that hold your hatchback up or something like that. It could be just one of those like gas strut rods or something, or just a shock absorber. It's really no way of knowing what it is. But assuming this moves in and out this way, well, that's almost right in line with a pivot point here, which can't work. So, you know, if this bell crank is rotating about this point, well, that's just going to swing that back and forth, which would swing this back and forth, which would do what here? I mean, there's no pivot here. It's almost as if this is just some kind of a made-up thing that doesn't actually do anything. So again, I'm kind of conflicted. I want to make it look like the model, but I also want it to kind of do something. So I decided to modify this just a little bit. And that's what I have going on right down here. So I basically just sketched out the rod, that point here, right here, that point here, back here. I took the measurements of the little actuator thing and drew them in here. And then I just made a bell crank and I put some tacks in it. And I just made a little plastic bell crank, put a tack at the pivot, another little plastic bell crank with a tack and a pivot, put a rod across them. This is where my actuator goes. And so now the idea is to have it do this. So again, if you can look in the kit, that bell crank was almost straight across. I just tipped it back a little bit so that the motion would translate more this way and less this way. And then this bell crank that just points straight back, I kicked it off at about a 45-degree angle here. So with this motion, you can go from 90 here to 90 there, almost. You know, it's not quite, but close enough. So for me, this will work. So I made 2 bell cranks like this, and again, looking at the kit part, it does have that little bend up, that little kick up, like that. And so I made 2 like this. This is just 3mm thick aluminum, and for the bell crank here, I made 2 of those. And I made a link rod, and I made an actuator here. Let's take a look at the parts for the actuator. So the actuator, you can see my drawings down here for the dimensions. Starts off with this piece, just an aluminum tube. This is just very basic, simple lathe work stuff, bored through with a hole in the end, so that's part of the actuator. And then we have a piston. I'm not sure exactly what it is. I have a box of radio-controlled helicopter parts, and I think this goes to a T-Rex 450. It's just a steel rod that's threaded on each end with a 2mm thread, which is convenient because my little ball joint here, that's also a 2mm thread. So this is going to be the shaft, and I have a 2mm bolt that's going to thread into the end of this, and that will become kind of the piston. And I have a spring. The spring goes on like that, and the spring won't go past the head of the bolt. And so this then goes into here. So we have this. So we have this like that. Another spring. Now you'll notice though that the springs are different lengths because the way this is going to move, the piston is going to be setting in here about like this, and it's only going to be able to move back a little bit, but it can move forward more. So it's going to be more like that motion. So it's going to be at rest here, come back to here, and then move more that way. So anyways, we'll put this back in here. We have a shorter spring that will go on that end. And then we have the end cap that will go here. And then into the end cap, we have that piece like that. Now that won't stay blue. This whole thing will get painted black except for the chrome part. All of that will be painted black. And then on the other end of this actuator, I have another ball joint that's plastic, and I have a 2mm threaded rod that will then go into the end of that, just like that. And that is the little actuator. And it can move in a little bit, and it can come out a little bit more. So this is that whole actuator piece. Now what I'm going to do, I'm going to bond all those pieces together with CA. Then I'm going to drill a little hole and insert a roll pin, and that will lock all of those ends together. So let's take a look at what all of this looks like installed on one of the rods. So there it is right there. Now this is not a final assembly, and by the way, the push-pull rod here, just a couple of those plastic ball joints, and in between is a spring steel wire and a brass tube that goes over top of that. And then that creates, and that's all just C8 together. And that creates that push-pull rod. Also, we can see here I have these mounted permanently with some copper wire wrapped around it here just to give that detail. But this is permanently installed here. And then we can see the bell crank here, and then you can see the movement of it. So that's, and it can go this way. That is the movement of that bell crank then, which I'm actually very happy with that. I'm pleased with that. Now, this is not, like I said before, this is not final assembly. For example, I'm going to put a little standoff right in there just so there's not a bell crank running on a round tube. So I'm going to have to find a piece of brass, make a little standoff to go under that bell crank. I'm also going to make some bushings and a standoff to go for this bell crank. And also that has to be spaced off. I just put a nut there for a temporary space, but same thing here. I'll make a little standoff for there as well. But that's what that all looks like, just like that. So again, it's not perfect for the model. It's not exactly the way the model is, but it's only slightly changed, and it actually does something. I mean, by that, I mean it can move, right? If I would have done it exactly the way the kit was, it wouldn't really do anything. It wouldn't really move. But yeah, I like it. I'm happy with that. So what I need to do now is the other side. Let me get this out of the way, just to give you an idea of what this looks like kind of together. Of course, that one goes there, and something like that. I cannot make the other push-pull rod here because I kind of screwed up and I didn't have enough. I didn't order enough of those ball joints here. So I just ordered some more. I should get those next week, and then I can finalize this right here. But what I'm going to do for now, I'm going to go ahead and just assemble everything that I can, and then I'm going to end this video because it's probably been way too long. Alrighty, there's what it's looking like so far, and it is getting close. Like I said, the next video for this, I want to do that area there and the handlebars, but just another little view. There's the front, little airfoils on the front, and the details on the front. And as we saw before, those are able to do this. I still need a couple of details to go here and here. I'll do that when I make all the little standoffs and the bushings for here. We have the details here, and so far I am very pleased with everything. Just to give you some different angles and different views of what it's looking like so far. And like I said, so far I am really pleased with the way this is coming together. But anyways, I'm thinking this video is probably way too long. I'm going to end this one here. As always, until next time, thanks for watching.